Hi, this is Always Eclectic Stacy. Welcome to 5-Minute Chemistry. You're in our covalent bond series, and today we're doing the fifth example of taking a covalent name and writing it into a molecular formula. Let's get going. Welcome back to Always Eclectic Chemistry. This is the fifth example of VSEPR and Lewis structures, and we're going to look at dicarbon, dihydrogen, dichloride. So this is a little tricky because multiple things are coming off of the carbon. So we're going to kind of look at it in pieces. So we're going to look at the electronegativity of carbon, hydrogen, and chlorine. So carbon has an electronegativity of 2.5. Hydrogen has an electronegativity of 2.1. So this is a difference of 0.4, and that's going to be right on the cusp of polarity. 0.4, 0.5 is just on that cusp of polarity. So if it was just carbon and hydrogen, it would not be very polar. But now we add in the chlorine, which is 3.0, and the difference between carbon and chlorine, carbon to chlorine, is 0.5, which makes it slightly polar. But the difference between chlorine and hydrogen is 0.9, which makes it polar. So this is slightly polar. This is very polar. So this is more than likely going to be, sorry, that was supposed to be 0.4, a polar molecule. So the next thing we're going to do, like always, is go ahead and draw our Lewis dots so that we can see the bonding potential. So carbon, remember, has 4 valence electrons. So we're going to draw carbon with 1, 2, 3, 4 dots, right, left, up, down, to show the 4 valence electrons. Hydrogen is always terminal because it only has 1 valence electron, so it only has 1 dot off to the right. And remember, chlorine is also always terminal. Oops, I dropped my pen. Because chlorine also only has 1 dot. So it goes 1, 2, 3, 4, right, left, up, down, 1, 2, 3. And you can see the single lone dot. Now, I only drew one example of each, but you can see how it works. Now, if you're wondering how carbon can support so many different bonds, remember carbon has 1, 2, 3, 4 bonding potential. It can make up to 4 single bonds, and seeing both hydrogen and chlorine both have single bonds, that is how this will work. Now, I'm going to go ahead and put carbon in the middle so you can start bonding. Now, we put carbon in the middle, and we're going to draw the 4 dots around it. Now, we're going to put a hydrogen here and a hydrogen here. And if you're wondering, it's because there's going to be a slight positive polarity towards hydrogen, and so they're going to be on one side of the pole. So I'm going to go ahead and draw in hydrogen here and finish my bond, and hydrogen here and finish my bond. And then chlorine's going to go on the other 2 bonds, making our negative dipole. Forget to draw in your extra Lewis dots so that you can model every single valence structure. Now, when we look at this, we have to remember to count our bonding pairs and lone pairs from our central atom. So we have 4 bonding pairs, 1, 2, 3, 4. So we have 4 bonding pairs. We have no lone pairs. And this is again going to be a tetrahedral. That's the molecular shape. But we do have to draw in the poles. Now remember, I'm not the best at this, but this is going to be a slightly negative pole, and this is going to be a slightly positive pole towards chlorine. This is our 5th example of VSEPR and Lewis structures, and this was amazing. Thank you so much for joining Always Eclectic Chemistry. Please don't forget to like and subscribe if you like these videos.